Cool. So we've got 2 minutes before the next session. So what I might do is really quickly go through the giveaways we've got today. So first and foremost, and this is because you'll need a bit of time to kind of get around this, there is a $50 Amazon gift card being given away by Arinti. There are a few requirements, so head on over to Twitter, tweet about the Global AI live tour that you're actually currently watching at, and reply on there. Just make sure you hashtag Global AI Community and that you're live from Sydney so that we can get it into the right streams and stuff, because there's one available for every stream. And make sure you're following Arinti on Twitter as well. So $50 to take your takeaway tonight, people. Why would you not do it? So head on over to Twitter, and if you want more of these details, they are available on the top of the banner with prizes. We've also got another giveaway from Microsoft, who are giving away a Microsoft swag box, not bag. If you complete the Cloud Skills Challenge, again, the details are all available on the website. Feel free to hop on over there to check them all out. And last but not least, there is also the Azure Heroes Learners badge available if you do want to get those credits. Just by being a part of the virtual tour itself, you're more than eligible. So head on over and get your badges everywhere that you want them. So with that, we will jump on over to our next speaker, who is going to be Praveen. So let me bring him into the stream itself. Praveen is joining us from India today, and he is an AI and ML enthusiast who will be talking about cricket analytics and prediction using ML.net. So Arafat gave us a pretty good intro into exactly what ML.net is, and Praveen's going to take it away from there and explain how you can do cricket prediction on it.
Exactly. Okay. Let me quickly share my screen.
Yeah, perfect. We'll get that on, and we will let you go off into the press of yourself. I'll get that into the stream, and you can take it away.
Okay. Just confirm me once you see the slides.
Yep, we can see it.
Are you able to see the slides?
Yeah, it's all good to go. I think we can hear you and we can see all your screens.
Okay. Thank you, and welcome to the Global AI on Tour 2021. And I'd like to take this opportunity to thank all the organizers of this great event, a multi-day event, which is going to upskill not only the newbies or the experience, but as a whole to the community. So let me get started with So agenda for my today's talk is about cricket, and so I'll be exploring a data set for the cricket. I'll be performing some data cleaning and analysis on that one. Then I'll be doing some analysis, a brief analysis using ML.net. I think Arafat has gave a great introduction to the ML.net framework. So thanks to Arafat on that one. Then I'll be doing some predictions using ML.NET followed by a small demo. So this is mainly a use case based presentation where I won't be going deeper into the ML.NET framework and what are the capabilities it has. But I'll be focusing mainly onto the cricket and the data set that it provides, which can be utilized for by the ML.NET framework to make some predictions and analysis on that one. Okay, a little intro about myself. So I'm working as a cloud architect at Harman. It's a Samsung company, and the domain I work for is professional audio, video, and control. And my area of expertise is cloud and distributed computing. Area of interest is AI, ML, and IoT, based out of Bangalore, India. I'm Azure certified and a .NET Foundation member. Okay, so before I go into the technical things, a brief about the game of cricket. So this is a game of cricket where you have a ball and a bat, and there are 11 players in each team. So they assemble together and play the game. So a brief history about that one is it was invented in 1550, originated by England. Sorry. So this was the first international match was played between Canada and USA in New York, and the first one-day international was played in 1971, whereas the first cricket World Cup was played in 1975, and the first T20 match was played in 2003. So if you see the history, so it's been a quite old game that has been prevalent from a long time. So a lot of changes have may been made throughout this transition from one format to the other format. So there are multiple formats that is being played as of today. So one is a one-day international, second one is test match, third one which got recently introduced is the T20. Then you have county matches, and the last one, but not the least one, is the IPL, that is the India Premier League. So some statistics about why the this game is so important and why uh, we need to focus on the data set that it generates. So it's a statistics of 2019 and 2020. So it is played by 104 nations. So IPL valuation is around $6.7 billion. It's a huge amount, and there's a huge viewer base on this one. So we have around 370 million viewers who are watching this cricket match. So there is a huge amount that is involved, and a lot. That's the reason a lot of companies are making good predictions, performing some good amount of analytics in the game of cricket. So for today's session, this is the problem statement. So we are going to perform an analysis on a cricket data set and predict the team score till 6 overs. So, and these are the tools and frameworks that I have used as of today. So I have used ML.NET, Jupyter Notebook, then .NET Interactive, then Azure Web App, Azure Function, and C Sharp is the language. And there is a pretty good library that I discovered while working on this one that is called as a Danny. So I'll brief you on that one as well. Okay, so the data set that I have used is downloaded from the crickseed.org, and it's a T20 matches for the men's data set. And the duration for the duration that it contains for the matches is from 2017 to 2021. So around like 4 years of matches it contains. There are 1010 matches that data set contains, and it has a team of 56. Features wise, it has 22 columns, and the total records it contains is around 231 K, and it is a mix of number and string. So as you can see here, the match ID is a number, whereas season, start date, we have date column also. You have venue, that is a string. Then inning is a number, ball is a number. So we have a mix of all these things in this data set. So what I did is first I did the data cleaning from this one, and for that I have leveraged ML.NET data frame functionality or the library, so which allows me to filter the data set to include till 6 over. The reason I have gone for till 6 over is I wanted to have it quite fast and with a low memory footprint. If I could have taken the full data set, but then the training time would have been more, and as this is for a representation purpose only, so I've tried to keep it as small as possible. Then I checked for the null values. Then if you look at this one, we don't have data for getting the number of runs per ball. So I wanted to see, because we have runs off bat and we have extras, so we don't know how many runs got scored for a ball. So runs off bat means the runs scored by the striker, whereas extras maybe like wide or like buys, those kind of things. But there is nothing for getting a data for scoring a run per ball. So for that, I need to do a aggregation using a data frame functionality from ML.NET. And there is another transformation that I had to do to get the value, for example, the cumulative sum. So I want, there's nothing for getting how much score is there per ball. For example, I don't know how much score is there after uh, second over, after third over, or after 2.3 overs, or after 5.6 overs. So those kind of, that kind of information is not available, and that is the main objective of our task today, is to predict the total score. So we need to do another transformation using the data frame and to calculate this one. Then I removed some of the features or columns from this data set, which is based on the uh, knowledge that I have with respect to the cricket, and feel that they are not relevant. So we could have done some feature engineering here as well by using different strategies that is available. But this is now on the based on the understanding that I have. So I have only considered only these 7 parameters as of now, and used that for making a prediction. So prediction wise, so this is basically a regression problem. Reason being, and some multi-regression problem. Reason being, we are using multiple parameters here to get the total score. So these are our different parameters that we will be using to get the total score. For example, you have venue, inning, whether it is the first inning or second inning, ball like 2.3 or 3.1 over, then batting team, then bowling team, striker, non-striker. So these are the relevant fields that I have chosen to come up with a score. So we know these are our input features, and this will be our output. And this is how I proceeded with this one using ML.NET. So we have defined the classes such as match score prediction. This is a typical workflow for any ML problem. You need to load the data set, you need to split the data set. So I have split it into 80/20. Then you have to have the one hot encoding. So that means you some of the features are not numerals. So they are like strings. For example, you have venue is a name, batting team is a name, bowling team is a name. So the computer, the ML algorithm doesn't understand those things. So we need to convert it into some numbers. So there, this one hot encoding comes into picture, and it tries to convert those things into these things, into numbers, which can be easily utilized by the ML.NET algorithm. And the algorithm that I have used is a FastTree. It's a tree-based algorithm, and why it is fast, because it's mainly very much similar to what we have for a binary search tree. So the problem will be divided into different trees, and the execution becomes very fast if we use this thing. So there are different algorithms available. I'll just showcase you about FastTree and a comparison with a couple of more algorithms here. And this is what the typical workflow, like you need to train, evaluate, and predict the model. So if I'm using my Jupyter Notebook, in that case, I'm getting a score for like a R square score. This is a matrix for a regression, any of the regression problem. You generally measure it using a R squared score or RMSE, root mean squared error. So I'm getting a 0.82 and RMSE as 6.73. And this is like a prediction with a sample data set. So wherein I have provided those fields, and based on that the prediction is done. So the predicted value is 24, whereas the actual one is 20. So as you can see, this is very much close to the actual one, so which looks like a very good model for our problem. And this is I did it using a model builder, wherein what it does, I have provided the same data set to the model builder, and it has generated different, it has internally ran that data set on different using different algorithms. So here they have used like GBM or stochastic descent algorithm, then fast tree. So as you can see, the best one out of this one is you can say the fast tree itself. So you got 0.8213, then you got 5.08. So RMSC loss is also very less, is comparatively good. So among these, I would say the best one is this one. Then I also leveraged this ML.NET, and I made a web app for this one. So based on that, the model that we trained was deployed on Azure Functions. The backend is deployed on Azure Functions, whereas the front end is a Angular, simple Angular app. And as you can see, you can select multiple things, all the parameters or the features that is defined in that, and you get a prediction. So for example, after a 2 over match, we got a decent value for a prediction, that is 11. So that is very much relevant in this context. Okay, and with that, let me take you to the demo part. Okay, so this is my Jupyter Lab notebook or IPython notebook, and I'm using the .NET Interactive. I have a C# kernel present here, along with the other kernels such as Python, then PowerShell, F#. So I'm using that one. So let me quickly run this. So this is the thing that is doing all the magic, the .NET Interactive. And this is how we load our packages. It is already done, so it will not load. Then I have just mentioned what are the using statements, what are the constants. Yeah, so here is the actual part that comes wherein so this is the actual API to load the data set. So I have my data set available. Once it is available, I am just loading it. So with this statement, I am loading my data set. So it is connecting to cricksheet.org, and from there it is downloading the data set. And after that, I'm performing some transformation. The data set contains uh, multiple files. So that after, see, you can see here that the data set is loaded now, and I have this merge CSV. So from this, I'll just do some cleaning on the data set. So what I'm doing, I'm just taking the data set till 6 overs. This is a preview of the data set using the data frame API that we have. So this is the file that got downloaded from cricksheet.org. And it has like 7,544 records after the transformation. So before transformation, it was 231K, but now as we are considering only till 6 overs, so it has been reduced to 75244. Now, then we are calculating the score that is based on the runs of bat and extras, and we are get, calculating the total score as well. So if you see here, we got we got the score thing got added, score column. Okay, so for getting the total score, I did some transformations on the data frame. Now if you could see that, yeah, I got the total score. So 00133, that means a sum of these, this plus this, then this plus this, like that it is happening, and it is adding till 6 overs. Now comes the feature selection. So I already told that I will be considering only the 7 columns here. So which I did, I removed the other columns. So now this is our final data set, how it looks like with these many columns. And yeah, so the problem I faced was there was no feature for multi group by on multiple columns. So I had to use an external library which I discovered while working on this problem statement. That is a Danny. So it's a .NET Data Analytics .NET library with the implementation of data frame, time series, linear. So a lot of features are present in this one. I find it very useful for manipulating the data set. So I'm going to perform the same thing using this library. So I'll just do it quickly. So after my transformation, and there was no way we can save the data frame as a file, as a CSV file using the trivial Microsoft data frame. So, but this library provides that functionality to save it as a CSV file. For example, this is the data frame which we can easily save using 2 CSV from this data set. So once everything is done, we get the cleaned data set, which is like this. So you have these many columns, and this is the output column, and rest is our input columns or the input features. So once that is done, now for making a prediction, we need to map these columns to a class that should be present in our system. So I created a match class which has all these fields, whatever is present in that data CSV file. And for getting the prediction, there should be a field such as total score, which is we will get what is the total score once we provide those many fields to our prediction thing. And this is how we load the data set using ML.NET ML context, which is very much similar to the DB context. It's a singleton object which is accessible throughout the life of this operation. So here we are specifying the path of the cleaned file, so which is nothing but here this file. So it will here we are also specifying that it has a header, which is true. Then separator is the comma. It can be tab also. So we will load this. So that means our file has been loaded into ML context. We will split the data set using the train trace split API. And point 2 represents how you want to split. That means we want to split it using 80-20 ratio. That means 80% is your training set and 20% is your test set. And this is how you create the transformation or the ML.NET pipeline. So first one is you copy the column. So we had that total score column in our data set that will act as a label or the output feature for our ML.NET problem. And these are the columns which are non-numeric, so they have to be transferred into numeric things, which can be easily done using this one hot encoding. So I have venue, batting team, bowling team, striker, non-striker, bowler. And so once we have these all things, I need to concatenate and create a single feature out of this one as an input. So this is the feature, and these are the values that get merged into a single feature. So once it is done, now I'm training the data sets. For training, I'm using the fast tree algorithm here. So this is the here you can make the change. A single line of change can be done for using different algorithms. And this is the fit method, which trains the model and gives you a model out of that one. So once we have the model, you do the you do evaluate on that one. So I'll just so this is a predefined API from ML.NET evaluate, where you provide the label and score. And this is how I get the output based on the or the metrics based on the algorithm that I have used, the fast tree. And this is how we save the model. So we say ml context.model.save. We specify the path. So this is the model file that got saved after this one. So this is a very small file, 193 KB, not a very big one, because the data set was small. So we'll do a prediction with some predefined values, a sample. So this is my sample, and based on that, I'll call the first I need to create a prediction engine which allows you to make the prediction. So it can be done for a single record, it can be done for a multiple records. So there is a separate API for doing a prediction on for multiple records. So I'm making a prediction for a single record only. So this is the predict method. We pass in the input or the sample, and we got this. So here you can see the actual score is this and the predicted score is this. So this is very decent one. And so this is from the Jupyter Lab notebook, but same I have from Model Builder also. So this is my Visual Studio where I'll be using the Model Builder, so a kind of a automated thing. So let me quickly do that as well. So here we specify the data. So I'll give this one. Yeah, so if you see, this has the same data set with same set of columns and the output feature. So here we need to specify what we need to predict. So we are going to predict the total score out of this one, and we are going to consider the all the columns that is present in that one, like venue, inning, ball, everything. So I'll just quickly train it. So let me train this. Yeah, so training is completed and best quality R squared is 0.82. So yeah, so if you see here, it has this time it has tried only SDCA. These are the two algorithms. It has this is SDCA only. It has tried this time. So you can see the score that we are getting here. It is 0.82, and this is how sample you can provide a sample input to evaluate how good is your model now. So I'll give it 2.4, and I'll just make a prediction out of this. And it says in 2.4 hours the score would have been 19, around 20 runs. So that is a very decent score which any team can make. So our prediction is going quite well here. And this is, if you click on the code, it will just generate the code, whatever is done by the ML builder, and you can leverage that one for making the prediction. So I'll not go into that one, but the last thing I want to show is the web app that is built, and it's using this model, and the backend is being deployed on Azure Functions. So if you see here, select this. I want to do the predict till third over. It takes a little time because it's on Azure Function. Yeah. So we could see, like, after 3.3 overs, the predicted score is 18.96. So that's also a decent prediction. So with that, I'll just go back to my slides. The improvement that we can make is using a large data set, feature selection strategies. There are different feature selection strategies, feature engineering altogether that we can apply. But to keep the thing simple, I have just to use few of them. And we can try with different algorithms that are present in ML.NET framework. The resources are available on, it's a getting started for ML.NET, and the slides and sources available here. With that, I conclude the session. Thank you for watching. Any questions you have, just feel free to ping me. This is my LinkedIn, not the LinkedIn, but yeah, Twitter handle. Thank you.
Thank you so much for that session. I don't think there's questions yet in the chat, but feel free to pop on over and we'll make sure your socials and stuff are available for others to join and reach out if they do have any other questions. Thank you so much. And for that, oh my God, one got another, look at those. We're actually sticking to the agenda so well today. Praveen, thank you so much for your time. We are very thankful of your session. And I mean, anything with cricket at this stage, I'm like, this is interesting. I've recently gotten into cricket, but like, amazing.
Yeah. A lot of viewers are there, so I think it's an interesting topic that I found recently that IPL was going on. So I thought of grabbing this one.
No, perfect. Well, we'll leave you go for now and feel free to hop on over to the chat. And now we've got